So this video is going to be both an introduction to the overall video series on running Apache Spark, Livy, and Airflow in Docker, as well as a quick demo of running PySpark jobs against a Spark cluster on Docker using the Bitnami Docker images. So we're going to start by looking at the Bitnami Docker Spark GitHub repo. And I do recommend looking through the documentation here. There's a lot of useful info, but essentially what we're going to do is take this Docker Compose file and extend it for our own use cases. Now I have made some customizations to the Docker Compose file. The first is downgrading the version to Spark 2.4.6. This is for compatibility with Apache Livy, which I'll be working on in a subsequent video. Additionally, I've added a volume to forward the log4j properties from my local machine to my Docker container. You can see the log4j properties in my conf directory, and the only change I made is changing the root category for logging from info to warn in order to minimize the volume of logs from our Spark sessions. Additionally, I'm setting two environment variables that you'll have to set on your local machine in order to get this to run properly. The first is the Spark master URL. Now, the Spark master URL should reference the name of your Spark master container. The name of our Spark master container is spark-master. So on our worker, we set our Spark master URL to be spark-master with the default port of 7077. I can set this as an environment variable locally using the export command in bash. And I can confirm that it's set with an echo. The second variable you'll have to set is the Spark driver host, and this will be the IP address of your local workstation, or in other words, where you're running your Spark driver. This is what our target architecture will look like in the end, with our Spark driver on our local workstation connected to a Spark master on a Docker container, which itself is connected to a Spark worker on a second Docker container. And that's what this Docker Compose file will help us achieve. There is one more prerequisite, and that's setting up your Python environment, assuming that you do want to run PySpark jobs against the Spark cluster. I've provided some instructions in the README on how to do this using Conda, which is my package manager and virtual environment provider of choice, but you should be able to use this requirements.txt file with another tool like pipenv or virtualenv. I'm going to go ahead and create my Conda environment now using the environment.yaml file. And you can see that our requirements are pretty basic. We're only installing PySpark 2.4.6 and request 2.23. And now my Conda environment is created, and I can activate it using Conda activate and then the name of my environment. So now it should be ready to get up and running. Now to start the service, we can go ahead and do a docker-compose up-d. I've already pulled down the images, so this is going to be pretty quick for me. But if you need to pull the images from Docker Hub, this will take a couple minutes. We can confirm that our two containers are running with a quick docker ps. And you can see that here we have our worker, and here we have our master. Now we can navigate to our browser, and we can go to a local host, 8080. And you can see here that we've got the Spark master up and running, and that we've got a worker connected. The first job we're going to run is going to be a simple Python app. You can find it here under Livy on Docker. and main.py. Now you can see here in our main.py that we begin by creating a Spark context, running a sample app, and then stopping the context. So let's take a quick look at our sample app. We start by creating some data. We've got 3 rows with employee ID as the first column and salary as the second column. And we're going to run a query to get the second highest salary from this data, which should be 200. Now going back to the main.py, you can see here that I have a helper method for getting the Spark context. And you can see here that all we're doing is setting the app name through a parameter passed to the getSparkContext function. So you'll recall that from the README, I had instructions to set the Spark master URL and the Spark driver host as environment variables. We can go ahead and do that now in our helper method for retrieving the Spark section by simply copying and pasting these 4 lines and dropping them inside of our conf.setAll list object. You can see here that I'm using os.environ.get in order to fetch the value for Spark master URL as it is set on my local machine. And if it does not exist, it will use Spark master 7077 as the default. Now make sure that whatever the value is for this environment variable matches the value used inside of your Docker Compose environment configuration for your Spark worker. Now we can go ahead and run our PySpark job. Now I've configured IntelliJ to use a Python 3.6 runtime and set this Python directory as the project source's root. So I can go ahead and click the run button and run main. This will go ahead and run my application, and I can now monitor it in the Spark UI. After I refresh this a couple times, I should see my application running, and we could see it now with the name of employees, which I set in my main method here. And you can see now that it finished and printed out 200. We can also see that it's marked as finished in the Spark UI as well. And that's it for this part of the video. In the next step, we're going to go over how to do this in Scala as well.